The Institute of Nanoscience and Materials of Aragón, INMA, is a mixed research institute from the Spanish National Research Council and the University of Zaragoza. From INMA, we promote the development of advanced materials that respond to the social challenges of the 21st century. The Institute aims to be a national and international benchmark for research in nanoscience and materials. Aragón Institute of Nanoscience and Materials. In a world of constant change and new needs, the study of materials gives us a framework full of possibilities. We investigate new materials that will allow a more efficient and environmentally friendly use of energy. We develop nanomaterials for biomedicine, oriented towards diagnosis of infection and disease, and to advanced therapies for various pathologies. We investigate materials and devices aimed at improving the performance of information technologies and exploring new paradigms, such as quantum technologies. We study physical phenomena and new states of matter at the nanoscale. We develop on-chip sensors and chemical microsensors, as well as innovative nanofabrication techniques. The Institute seeks to generate new knowledge, develop applications that provide solutions specific to the current challenges of our society, and transfer our research from the laboratory to the general public. INMA is committed to bringing science closer to society, explaining the wealth of benefits that our research provides. Currently, INMA is comprised of more than 300 people, and many more are set to join in the future thanks to our training programs and diverse talent acquisition. Our core objective is clear: to contribute to the advancement of knowledge in nanoscience and technology of materials. At INMA, we cover the entire process, from basic research to development and transfer to society. Our tool, our people, their creativity, efficiency, and talent. At INMA, excellence is not the goal, it is the path.
The Materials for Energy and Environment area works on nanomaterials and functional materials, their processing and incorporation in devices, looking for a more efficient energy use and environment protection. There are research lines centered on the development of porous materials and membranes that allow the capture of pollutants present in air or water. Other research lines focus on the development of materials for energy storage, used in fuel cells or different battery types, as well as in electrolyzers for hydrogen production. We also work on new materials and devices with magnetic properties that are introduced in efficient refrigeration systems that are able to work at room temperature and at very low temperatures. We also work on new materials and devices with magnetic properties that are introduced in efficient refrigeration systems that are able to work at room temperature and also at very low temperatures. We also work on carbon materials obtained from biopolymers that are used as sorbents for pollutant removal or as catalysts. Finally, some of the last materials developed at the Institute are materials able to be activated by electromagnetic radiation and active in the transformation of carbon dioxide into valuable products, a fundamental reaction for environment protection.
this INMA's area, we work together on the synthesis and the functionalizations of advanced nanomaterials for biomedical applications. In the area of diagnosis, we develop innovative nanobiosensors to detect different analytes, such as pathogens or tumoral markers with high sensitivity. In the area of therapy, for instance, we use nanomaterials for controlled drug delivery or tissue regeneration, and we also develop stimuli-responsive nanomaterials to mitigate the resistance of microorganisms to antibiotics. One research line with great potential is the use of nanocatalysis for the selective and remote generation of drugs in situ, at the point of interest to avoid adverse effects of conventional therapies. Finally, we often take advantage of the heating properties of different nanoparticles to develop new biomedical applications.
Anything outrageous characterizes itself by the access to ingent amounts of data. At INMA, we are developing new materials that in the future will help us to store more information in less space and in a more ecosystem-friendly way. We are also developing new devices, nano and micro sensors that will help us to process, read out and store this information even at the level of a few molecules. At this scale of size, nature begins to show evidences of its quantum nature. One of the pending revolutions of the 21st century is to exploit these quantum phenomena to do actual technologies. At INMA, we are developing quantum sensors that in the future will be able to detect magnetic materials and also be helpful for the early detection of diagnosis of diseases. And we are also developing our own quantum processor that is based on the combination of magnetic materials and superconducting circuits that we hope will help to solve some of the challenges that this technology is facing in order to reach actual applications.
Well, in this area we focus on the theoretical and experimental study of the physical phenomena at the nanoscale. That means to build nanomaterials which are essentially of two kinds, nanofilms and nanoparticles. The nanofilms are used for sensors, for example, and for design of new circuits that consume very low energy, and also for neuromorphic circuitry that have some plasticity. The magnetic nanoparticles, on the other side, are used in two main fields that are biomedicine and catalysis. The catalysis is for the recuperation, the recovery of contaminated water in large sources, and in biomedicine we use the nanoparticles for stimulating cells or kill some cells, like in cancer. We also count with the facilities of the advanced microscopy laboratory, which allows us to maneuver with small materials at the nanoscale, again for sensors and catalytic processes.
The implementation of a new material is a collaborative process that implies the synergy of several disciplines. At INMA, we investigate the different stages of this process. The structure design is performed by theoretical calculation and molecular simulation. We also investigate synthetic strategies based on classical or dynamic covalent chemistry, click, bioorthogonal or supramolecular chemistries, or controlled polymerization to prepare organic materials or polymer for application in topics of interest in our institute, such as energy or health. We also carry out intense research in innovative techniques for processing nano and microstructures, as the assembly of two-dimensional materials, metal organic frameworks, in DNA nanotechnology, electrospinning of fibers, 4D printing, or in laser surface modification of materials. In particular, in this technology, there is an intense collaboration with industrial partners. In case of scaling, For example, the optimization of microfluidic devices and continuous synthesis with laser are investigated.
The Aragón Institute of Nanoscience and Material has a set of unique experimental techniques located at the technological forefront, which provide added value and a unique character to our laboratories. Among the research lines developed in these laboratories, we can highlight nanofabrication with dual ion and electron beam microscopies, as well as characterization of materials at the nanoscale, with ultra-high resolution transmission electron microscopes, scanning electron microscopes, and local proof microscopies that belong to the Laboratory for Advanced Microscopies, the LMA, which is a national facility in Spain. Important is also a transversal research line for materials characterization in collaboration with the ILL, the Lou Langevin Institute, focused on in-house developments of new facilities and also in the preparation of proposals and development of experiments in international large facilities. Another field of research at INMA is the generation of sensors for non-conventional experiments, micro-hole sensors, microsquid susceptometers, nanosquid sensors, nanocalorimeters, and superconductor-based radiation detectors. Very relevant is the development of cutting-edge technologies for the recycling and efficient use of helium, with milestones such as distribution in more than 15 countries of our technology. And finally, the preparation of chemicals, microsensors and contactors aimed at the detection of volatile organic compounds, industrial pollutants, explosives, etc., using microcantilevers, surface enhancement Raman spectroscopy, or microfluidic devices, among others.
In addition to lines of research that address specific challenges, INMA also has transversal lines of research that range from the synthesis, processing and scaling of nanomaterials, the development of advanced scientific instrumentation, to the activity in state-of-the-art facilities at a national and international level, the well-known cathedrals of science. To support all the research we develop, INMA has created several units. The Scientific Culture Unit, which organises a broad range of societal engagement and public dissemination activities for the general public. The Technology Transfer Unit, whose mission is to publicise our scientific and technological capabilities and align our research with the needs of the industrial and technological sectors, creating synergies and joint research projects. International Relations and Projects Unit. Science has no borders. And of course, an intrinsic characteristic of INMA is its internationalization. We collaborate with a vast number of international organizations, universities, research centers, companies, and of course we have researchers from different nationalities who carry out their work at INMA. We coordinate more than 30 international projects and are involved in many more. The Microdevice Engineering Technical Unit, created with the aim of improving the level of technological maturity of the microdevices that are being developed in the Institute and be able to transfer them to the industrial sector. In addition to these support units, the Transversal Research Support Services of the University of Zaragoza and the Centre for Materials Chemistry of Aragón give us rapid access to the techniques we use to characterize the advanced materials that we develop, including NMR, mass spectrometry, chromatography, spectroscopy, thermal analysis, elemental analysis, X-ray diffraction, and so on. Linked to INMA is the Laboratory of Advanced Microscopies, a singular scientific technical infrastructure, a benchmark in Spain in the field of nanofabrication and electron microscopy. The INMA Management and Administration Team enables and facilitates the development of the INMA research activity. Importantly, it is strongly implicated in teaching activities at the University of Zaragoza with active participation in the undergraduate, master's and doctoral levels, and is committed to the training of researchers and professionals specialized in the most advanced research topics. The Institute of Nanoscience and Materials of Aragón is at the forefront in the use of the transformative power of nanotechnology and materials science to address the most urgent needs of society. Our mission is to be pioneers in the development of revolutionary advances in various sectors, such as health, energy, quantum technologies, and many others, prioritizing the integration of knowledge from various disciplines while promoting a culture of scientific excellence. At INMA, we work together to contribute actively to the construction of a sustainable world. Aragón Institute of Nanoscience and Materials.